Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Stretchy Arrows by Monotov. And here are the rules. Excuse me. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. An arrow in a cell with a digit n indicates that the next n cells in the arrow's direction sum to n squared. So, what does that mean? An arrow in a cell, so say we had 3 here. That would mean the next 3 cells in the arrow's direction sum to 3 squared. So the next 3 cells in the arrow's direction must sum to 3 squared, which is 9. So you could have 1, actually in fact you would have to have 1, 2, and 6 here for this to add up correctly. And so say we had a 3 here, then that would mean in this direction the next 3 digits add up to 9. These 3 digits must add up to 9 also. Interesting. Those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So 1 can never be in an arrow because you can't have 1 digit adding up to 1 in the same row or column with another 1. So that's not possible. 2 could work. The next 2 digits must add up to 2 squared, which is 4. 3 works with 1, 2, 6 specifically to add up to 9. 4 to 16 is more varied. So you could have 2, 3, and 4. 5 is also more varied. 5 adding up to 25 works. So 2 through 5 works in general. 6, 2 and 3 are very specific though. Excuse me. 6 digits adding up to 36 without a 6. Is that possible? Probably, right? That would mean the other 2 remaining digits. So 36 digits. So you can't have a 7 ever there because 7 digits can never add. 7 unique digits can never add up to 49. 36 does work if it's followed by 3, 4, 5, 7, 8, 9. 12 plus 24. Okay, so 6 is very specific. So these arrows have to be 2 through 6. But we also are limited by how far it can go. So this has to be 2 or 3. Because we can only get 2 or 3 digits this way. So this is guaranteed to be 2 or 3. Everything else is not that limited. This is 2 through 5. Because it's limited 5 going this way. Everything else is 2 through 6, I think. This is 2 through 5 also. So if this is 2, this has to be 1, 3 going back. So this would have to be then 3 with 1, if that's the case. If this is 6, or sorry, if this is 3, this must be 1, 2, 6 adding up to 9. So this can't, well, this could be 2, or it could be 6. You could have 1, 2, 6 there, and we don't, this could be 1, 2, or 6, but we are not certain. So we know this cannot be 2, because we're guaranteed 2 in one of these 4 cells. Cannot be 3, because we have a guaranteed 3 in one of these 4 cells. Obviously can't be 1. So we're guaranteed in this set, it's either 1, 2, and 3 in some sort of order. So this can't be 1, 2, or 3. It could be 4, 5, or 6 there. Hmm. Okay, so we are guaranteed, actually, 3 doesn't have to be here. 3 has to be one of these two guaranteed. What else do we have? Okay, this is in both directions. It can't ever be 2, because if it's 2, that would be 1, 3, 1, 3, and obviously this 1, 3 pair would eliminate all pairs for 1, 3 being there. So this can't be 2. It's either 3, 4, or 5. 6 is very restrictive. 6 would require all of these digits to be, again, what would it require? It would require them to be 3, 4, 5, 7, 8, 9, which is not possible. So this cannot be 6 this way. So we have 4 or 5. If we tried to have 5 here, well, you could not have 2 there if that's the case, because 2, 1, 3 is 6. 25 minus 6 is 19, and 2 digits are never going to add up to 19. So could we have 3 here? 3, 2, 6 is the minimum. You couldn't have 3, 2, 1 in general, because that wouldn't work. Okay, so these digits are 2 through 6 on all of these places. If this were 2 and 1, 3, the problem is this wouldn't have any options. Because 2, 1, 3 would be eliminated as possibility. 3, 1, 2, 6 would be eliminated as a possibility. So this can't be 2. Can this be 3? If this is 3, you could have 1, 2, 6 here. This wouldn't be 1, 3 available, and it wouldn't have 1, 2, 6 because there would be too many digits, too many cells in this box requiring 1, 2, 6. So this can't be 3 either. Hmm. Okay. Oh, this can only go 4. 1, 2, 3, 4. So this cannot be 5 or 6. So that's important. But we don't have as many restrictions as the 2 or 3. These must be 3 different sets. Three different digits, essentially. This cannot be 6. If this is 6, that means these 6 digits must add up to 36, which would mean we'd have to have 1 and 2 here, which is not possible. So these digits have to be 4 through 9. Interesting. So this cannot be 2, because if it's 2, this would have to be a 1, 3 pair, which is not possible. It could be 6, though. 6 is certainly possible. 3 doesn't work, because 3 requires this to be 1, 2, 6 also. So this is 4, 5, or 6 also. Interesting. So if we have 5 here, these would add up to 25. So 25 plus 5. How would that work, essentially? So if we have 5, this must add up to 25. We have this is most this could be then, would be 3, 2, and 6. You can't have 3, 1, 2. That's just not going to work. Can you have 3, 2, 6 lead to something, or 3, 1, 6 lead to something? So 25 minus 3, 2, 6 is 11. So 25 minus 11 is 14, which means these would have to be 5 or 9 or 6 or 8, neither of which works. What about 3, 1, 6? Obviously 3, 2, 1 doesn't work, but 3, 1, 6 could work. Then 25 minus 10 would be 15. You don't have 6 available. This would have to be 7 and 8. Interesting. So it'd have to be 7 and 8, which seems to work perfectly fine. So 3, 1, 6, so it'd have to be 3 here, 1 and 6 in this set. So 1 here, 6 here. This would be 2. You'd have 7, 8 here and 4, 9 there. So that seems to work for 5. So, where's 4 then in this row? Either 4 is here, or if 4 is not here, that means this is 5, which means this must add up to 25, which means it specifically must be 3, 1, 6. 3, 1, and 6 there. Why can't this be 1? It should be able to be 1. Huh. Okay. 3 with 1 and 6 here, that would force us to be 7, 8, which means 4 has to be one of these 3. Interesting, which means this cannot be just 4. It has to be 5 or 6 here. So 4 cannot be here. 4 could have a lot of combinations, unfortunately, so that's not helpful. If this is 6, it has to be 3, 4, 5, 7, 8, 9. Interesting. Okay. Otherwise, this is 5 here, which means this has to be 4. So 5 couldn't be one of these 2 digits. Can 5 be here in that scenario? 1, 2, 5, and 8 works. Or you could have a 5 just be there too, potentially. We know these are guaranteed to be 1, 2, 3, and 6. Wait, why can't this be 3 here? This should be able to be 3. Right, because if it's 2, it's 1 or 3. In some scenario. I don't know why. Oh, so 3 has to be one of these 3. Well, okay, that doesn't change very much. I don't know how I got 2 and 1, 3. Oh, because this can't be 1. Okay. And because that can't be 1, this can never be 3 here because there's an arrow here. That's the reasoning. Okay, so if this were 6, that actually works. 3, 4, 5, 7, 8, 9. We can't have 2 here because that would require 1 and 3 to be there, so this cannot be 2. Can we have 3 here? We can't have 3 here because if we had 3 here, these would have to add up to 9 with 1, 2, and 6, but we have a guaranteed 1, 2, or 6 here. So this must be 6, which leaves this as 3, adding up, and then this must be 1 and 2. Aha. Very cool. Okay, so we have 1 and 2 here. This is 6, so this cannot be 6 here. That eliminates 6 in the rest of the row. That means... Can you add up 4 digits here to add up to 16? Well, 3 and 6 is already 9. 16 minus 9 is 7. And 5 and 7 at minimum is 12. So no, this cannot be 4. This has to be 5. Which makes that 6. That's interesting. This has to be 7, 8 as a pair. The first 5 digits, it must be... So 3, 7, 8, 6, and 1 here. So this is 1, that's 2. This cannot be 2 digits because it would require these 2 digits to be 1 and 3. So no 2 here. This has to be a 4, 9 pair here. So again, this must be 3, 4, 5, 7, 8, 9, and this must be a 1, 2 pair here. So this cannot be 3 here, adding up. Can it be 5? Well, remaining digits of box 3, we have 1, 2, 3, 5, 7, 8, no 5s. 1, 2, 3, 7, 8. Okay, this can't be 1 or 2 because of the 1, 2 pair in the column. Also, this 1, 2 pair eliminates 2 in the rest of the box. Okay, 4 or 5 going this direction. Remaining digits of box 1, we have 3, 4, 5, 7, 8, 9. Okay. Remaining digits of box 2, we have 1, 2, 4, 5, 6, 9. And obviously 6 can't be here because of 6 in the row. Five eliminates 5 from being here. This can't be 6 any... Well, it could be. Remaining digits in box 9 are 3 through 9. No 6 here, no 5 here, because of 6 and 5 in the columns. This must be 3, 4, 5, 7, 8, 9 here. If this were 4, that would mean this has to be 3, 5, 7, and 1 to add up to 16. So that does work there. What about if this is 5? If this is 5, these add up to 3. So 25 minus 3 is 22. So this would have to be either 5, 8, 9 or 6, 7, 9. But the problem is those are already taken by the 5 here and the 6 here. So this cannot be 5. Right? Because 25 minus 3 is 22. The only 3 digits that add up to 22 are 5, 6, 9, or sorry, 5, 8, 9, and 6, 7, 9, both of which would be taken by this being 5. So this cannot be 5. This must be 4. And again, this has to be 3, 5, 7 at minimum. That's 15 plus 1, which adds up to... these 4 add up to 16, which is 4 squared. 4 eliminates 4 here, so that's 9, which makes that 4. This cannot be 3 or 7 because of the 3, 5, 7 triplet in the column. So this must be 8, which eliminates 8 in the rest of the box and rows. 4 eliminates 4 in the rest of the column. Okay. This still could be 6 here. That's still perfect. Okay, 4. We don't have very much information. 4 is very wide, so is 5. Let's see. This could still be 6 here. That is fine. Can it be 3 anymore? No, it requires 1, 2, and 6 to be there. So this cannot be 3. So this has to be 5 or 6, adding up to 25 or 36. Okay. Can this be 6? The answer is no, because if this were 6, these digits would have to be 3, 4, 5, 7, 8, 9, which would require 2 to be there, but 2 was already in that box. Can it be 3? The answer is no, because if this were 3, then these would have to specifically be 1, 2, 6, but we have a 1 in the row, so this must be 4 here. That eliminates 4 in the rest of the row and box. Can this be 3 then? The answer is no, because if we have 3 here, it has to again be 1, 2, 6. We don't have 1, 2 available, so this is 6, which makes this a 1, 2 pair. Here, this is not 1, 2 because of the 1, 2 pair. 6 eliminates 6 here, so this is 5. That means this can't be 5 here. No 6 here, no 5 or 6 here. So these have to be 3, 7, 8, 9. Okay. So now we have a 3, 5, 7, 8, 9 quintuplet in box 6, which eliminates 3, 5, 7, 8, 9 in the rest of the box. Also, 3, 7 eliminates 3, 7 here. It's 8, 9 as a pair, which eliminates 8, 9 in the rest of the box. So this is 3, 7. That leaves us as 1, 2, 6. We have 5 digits adding up to 25 here. And we have 3 and 7 already. We have what digits of, so this must add, so this right now adds up to 15. These 3 must add up to 15 because 10 plus 15 is 25, which is 5 squared. So this is 15 and this is 15. Interesting. So the two 15s have to be then 2, 4, 9 and 1, 6, 8. We just don't know which. 4 going that way, 4 going this way, without a 1. So adding up to 16 without a 1 and without a 4. Does it have to be 2, 3, 5, 6? What's the minimum? 2, 3, 5, 6, which does add up to 16. 2 and 6 is 8, 3 and 5 is 8. So this must be a 2, 3, 5, 6 quadruplet, which means the rest of the row is 7, 8, and 9. And we have to have a 7 be in one of these two cells. Okay. This can't be 2 because of 2 in the column. 3 doesn't work because this is 7, 8, or 9. So this has to be 4 or 5 here. So 2, 4, 9 and 1, 6, 8 is available. Okay. 6 eliminates 6 here. So where's the 6 in row 8? It must be one of these digits. So this is 6, which means this cannot be 1, 6, 8 to add up to 15. It's 2, 4, 9 here. So we know this is 2, 4, 9, which eliminates 2 in the rest of the box. So this becomes a 3, 5, 6 triplet. That eliminates 3, 5, and 6 in the rest of the row. So this can't be 3 or 5. It's 2. And this must be 1, 6, and 8, which eliminates 1, 6, and 8 in the rest of the box. This can't be 1 because of 1 in the column. No 6 here because of 6 in the column. So this can't be 8. It's a 7, 9 pair, which eliminates 7, 9 in the rest of the row. This can't be 9. It's 8, which makes this 9. Remaining digits in a row in this box 7 have to be 3, 4, and 5. Remaining digits in... So this has to have a 2 here, interestingly enough. The remaining digits in row 9 are 1, 7, and 8. Okay, 3 eliminates 3 here. Um, okay. So we have a guaranteed 2 here, which means this could be 3 with 1, 2, and 6 adding up. What about... Okay. Can this be 6? If this is 1 and this is 2, yes. Hmm. Um... If this is 5, we are guaranteed a 1 has to be one of those digits. We also are guaranteed a 6 has to be one of those digits. So the remaining 3 digits would be 25, which is 5 squared, minus 1 and 6. So 25 minus 7, which is 18. That certainly seems feasible. Oh, we have a 4-5 pair in column 1, which eliminates 4 and 5 in the rest of the column. Okay. That means remaining digits in column 1 are 1, 3, 6, 7, 8, and 9. Okay. So without 4 and 5. So for 5, it would have to be... Without 4 and 5 available, to add up to 5 digits, so this would be 30 here, which means this would have to be 15. So it would have to be 2, 4, and 9, which is feasible. Um, hmm. If we had 5 here, does that work? Again, that means total this would add up to 30. So this would have to add up to 15. Can it add up to 15? The answer is no, because minimum is 3, 6, and 7, which is 16. So this cannot be 5. So either this is 3, which makes this 2 here and 6, or this is 4, which again requires 1 and 2 here. What else would it require? So 1 and 2 is 3. 16, which is 4 squared, minus 3 is 13. So no 4, 9. It could be 2 with 5 and 8. Or 2, 6, 7. So 6 can't be here, so this would be 2 and 6 in that case. We have a 2, 6, 8 triplet now in column 2, which eliminates 2, 6, and 8 in the rest of the column. So no 8 here. One of these is 7 or 9, interestingly enough. Okay, can this, if this is 5 here, then this would add up to 25 here. So can this add up to 15? 187, no. 183, no. 283, no. 287, no. So this cannot be 5. This has to be 4, which makes this 5. So then this must be 2, 4, and 9, adding up to 15 here. And that leaves this as a 7, this as a 9. This can't be 7 or 9. So we have a guaranteed 3 here. We cannot have both 6 and 8 here. So if we had 1 here, that would force 6 and 8 to be here, which would eliminate all possibilities for this pairing. These can't be 9 anymore. There's no more 9 here. This can't be 4 here. This can't be 4 here in this box. So this has to be 1 here. So therefore this can't be 1 here. Because again, if we had 1 here, that would force 6 and 8 to be here, which would eliminate one of the possibilities, or all possibilities for this pair here. So this is 6, 8 as a pair, which means this can't be 6 or 8. It's 1. 5 eliminates 5 as a possibility here. This becomes a 3, 4 pair in column 2, which eliminates 3 and 4 in the rest of the column. So no 3 here, no 3 here. This becomes a 5, 7 pair, which eliminates 5 and 7 in the rest of the box. So this can't be 5 or 7, it's 3. This can't be 3, 5, or 7, it's 8. 3 eliminates 3 here, so that's 4 with 3 there. That eliminates 3 here, so that's 4. So we know that it's 1. Right, it has to be 2, 1, 2, either 6 and 7 or 8 and 5. We're not sure which. 3 eliminates 3 here, though, so it's 7, and that's 3. That means this can't be 7, so it's 5 and 7 there. We celebrate because we're getting close to solving it. No more 5 allowed here. So these 4 digits must add up to 16. So it must be 1, 2, 5, and 8. So this cannot be 8 here because of the 2-8 pair in the row or column. So that's 6, that's 8. Again, no 8 here. Remaining digits in column 3 are 5, 7, and 9. Okay, so these add up to 16 also. And we have 3 and 5 here, that's 8. So the other 2 digits must add up to 8. And the only 2 digits that do are 2 and 6. So this is a 2, 6 pair, which eliminates 2 and 6 in the rest of the row. So this can't be 2. It's 1, which makes that 2. This can't be 1, 2, or 6. It's 9. So there's no 2 here. It's 1, 4, and 5. Okay. Can this ever be 6 again? And the answer is no, because if this is 6, that means these 6 digits includes a 2, which is not going to add up to 36 with the other 5 remaining digits. So this cannot be 6 here. These 4 digits must add up. Well, we already know that. Okay, so that's done. This 6 is done. So which ones are done? This is done. 6 is done. 3 is done. 6 here is done. 5 is done. 4 this way is done, but not this way. 5 is done. 4 is done. 6 is done. 5 is done. 4 is done this way. So we just have this one and this one. So this is 4, which means this adds up to 16. That's 20 for these. 25. So these 4 digits must add up to 25. This is 6 at most. You can't have 1 here, because 1 would require 7, 8, 9 to be here. So this can't be 1. I don't think you can have... You could have 2. 2, 6, 8, and 9 actually does work. That's 25 for those 4 digits. But you can't have 1 here for the same reasoning, right? 1 would require this to be 7, 8, and 9 to add up to 25, because these add up to 20. So 1 cannot be here, which means where is 1 in this row? It has to be here. Which eliminates 1 from being here. This can't be 2 anyways, because if we have 2, this would have to be 1, 3 as a pair. So 2 can't be here. Can this be 3? The answer is no, because it would require 1, 2, and 6 to be there. So this must be 4. So this is 4, which eliminates 4 here. No 4 here. So can this be 3 anymore? The answer is no, because if it's 3, this must be 1, 2, 6, adding up to 9, which is 3 squared. So this must be 5 here, which makes this 6, which makes that 3. 5 eliminates 5 here, so that's 1. No 1 here. Again, that means these 6 digits add up to 30. So these 3 digits must add up to 15. And we can't be 1, 2, because the other digit would have to be a 12, which is not a digit. So it must be 1, 6, which makes that 2, and 8, which adds up to 15 there. So this is 7, that makes this 8. No 8 here, no 8 here. This is done then as a region, or as an stretchy arrow. 4 here. Okay, we'll have to figure that out. Remaining digits in column 5. We have 2, 3, and 9. So one of these is guaranteed to be a 3. So this is done that way. It's not done here. So again, this is 20. These must add up to 25. Can we have 3 here? So 2 works with 6, 8, and 9. Can this be 2 then? The answer is no. If we try to have 2 here, we have 6, 3, and 9 at most here. Or as the basically what's required. It would be 6, 3 plus some other digit. Wait, does that work? Well, can't. Okay. Hold up. If we had 2 here, this is 6, that would be 3. And that would already be too small. 2, 3, and 6 only adds up to 11. And therefore, this digit would have to be 14, which is obviously not going to work. So this cannot be 2. This must be 8, which makes that 2 there. So this cannot be 2 here. So these 3 digits must add up to 25 minus 8, which is 17. Okay. Can you have 3 here? 3 and 2 is too small, obviously. 3 and 6... 2 eliminates 2 as a possibility here. 9 eliminates 9 as a possibility there. 25. So 17, 3, 6, and 8 add up to 17. So this cannot be 3. Therefore, that forces this to be 6, which makes this 2. So this must be 2, 6, 8, and 9 to add up to 25. And the 2, 9 eliminates 2 and 9 here, so that's 3. This can't be 3, 8, or 9. It's 7. That eliminates 7 here, so it's 3 and 7 there. No 7 here. No 3 and 7 here. It's 8, 9, and no 2 here. That leaves this as a 1, 5 pair. Does that add up to 16? 1, 3, 5, 7? Yes, it does. 1 and 7 add up to 8, so does 3 and 5. Okay, 3 eliminates 3 here. These 4 must add up to 16 also. Okay. Remaining digits in box 5, we have 2, 6, 7, 8, 9. 2 obviously can't be here or here. 6 can't be here or here because of 2 and 6 in the column. This can't be 2 because of 2 in the row. So, what's the minimum here now? It's 1, 2, 5, and 7. What does that add up to? 1, 2 is 3, plus 5 is 8, plus 7 is 15. we can only go up 1, so these can't go up 1 only. So this has to then be 1 and 5 with 8. 1 eliminates 1 here, so it's 3. 5 eliminates 5 here, so it's 7. 8 eliminates 8 in the rest of the box and row. 8 eliminates 8 here, so that's 9 and 8. 1 eliminates 1 here, so it's 6 and 1. 5 eliminates 5 here, so it's 3 and 5. This can't be 6 or 9. It's 7, which makes that not 7, so that's 9, which makes that not 9. It's 2, which makes that 9, that 4, that 2. 4 eliminates 4 here, so it's 5 and 4. 5 eliminates 5 here, so it's 1 and 5. This is remaining as a 6. 7 eliminates 7 here, so it's 1 and 7. And that's a solution. Yeah, fairly straightforward. Just a lot of math involved. I was just curious about the rule set here. Yeah, it's just a lot of math, really. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.